We're now going to make a series of videos where we're going to start looking at trees. And the primary difference between a tree and a linked list is that linked lists are laid out in a linear fashion. You start at some node and you can go to the left or to the right. With a tree, well, you can go previous or next. Now, I'm about to say with a tree you can go left or right. Actually, with a tree you have a node, and that node can have branches. It can actually have many branches, as many as you want. We're going to look at a particular brand of tree called a binary tree where each node has two branches. And so you have a root. It has branches. Branches can have branches. Where you have a terminal node, a node that doesn't have any branches coming off from it, those are actually called leaves. This tree has 3 leaves, 4, 2, and 1. This tree has a depth of 3. So we have a node at this level, 2 nodes at this level, and 2 nodes at this level, and there are 3 different levels to this tree, so depth of 3. And what we're going to look at is how you can add things into this tree, how you can print this tree out, and basically how you get around inside of this tree. And the thing that's interesting about trees versus linked lists is the easiest way to do this is actually to do it recursively. Alright, so we're going to look at actually this example, and I'm going to code this example and show you how to print it out, or one way to print it out. So first we're going to build, like we did before with linked lists, a node class. You can have data, and you can have a left branch, and you can have a right branch. So data, left, and right. And we have a string method which just prints that data out. Okay, now we have a tree class. The tree class is going to be made up of nodes. The init method just sets the root, and the root is actually going to be one of those node classes. Then we have the string method, which is executed recursively. So it takes this tree, whatever shape it's in, and makes a string out of it, and the string is going to be called s internally. So the way this works is we set up s to be the empty string, and then we traverse the tree. So we're going to look at different ways of doing tree traversals. And the one that we're going to do is an infix traversal. Alright, so traverse, this is a recursive method, and it traverses from the current node whatever you pass in it, and initially we're going to be starting at the root. We set up s again, so this s, I've declared it to be non-local, which means use this s out here. And then what we're going to do is we're going to go left as far as we can. When we get left as far as we can, we're going to add the current node to the list, and then we'll go right as far as we can, and then we'll sort of back our way out. So let's look at how this works. Looking at this tree, 5, 4, 3, 2, 1, we start the traversal at 5. So we come in and we're at node 5, and it says, is the current node dot left not none? Well, at 5 you can go left to 4, so that is not none. So we traverse with the current node dot left. So now we're traversing with that node 4. So we come back up to the beginning of this, again with a non-local s, which says we're working with this s. We check, is current node dot left none? Well, now we're at node 4, and the left is none. So the next thing we do is we add that node to the string. Actually, it's the string of that node to the string. So we're putting 4 onto the string. Then we check to see if we can go to the right. So we check, is the current node dot right none? And it is none because we're at that node 4. There is no right. So we're done with this. So we're done with traverse for node 4, which means we go back to where we were with node 5, which was at right here. This is what we called traverse with node 4. When we were in node 5, so we finished that. Now we're going to finish executing for node 5. And it says, is the current node not none? For node 5 it's not none, so we're going to add that to the string. And then we're going to check, can we go right? And we can go right at node 5. So we're going to go to the right to node 3. So this is going to call traverse with the current node dot right. So it's going to call traverse with node 3. We get s. Can we go to the left? Yes, we can go to the left to the 2. We go left to the 2. We call traverse with that. With 2, we can't go to the left anymore. So we add 2 to the list. We can't go to the right from 2. So when we're done with 2, we come back to 3. We were here with 3. Now we go to here. 3 is not none, so we add that to the list. And then we check, can we go to the right? We can go to the right. So we go to the 1. At the 1, we can't go to the left. So we add 1 to the list. Then we can't go to the right. So we're done. And once we get here, we're done. And we start backing our way up. We go back to the 3. The 3 at this point was here, so the 3 is done executing. So we're done executing with the 3. We go back up to the 5 where that was. The 5 was at this point in its execution. It's done. And when it's done, that was the root. It comes back. The traversal of the root is finished executing. And we return the string S. And when all of that happens, well, we should get 5, 4, 2, 3, 1. 5, 4, 2, 3. Should get 4, 5, 2, 3, 1. Yeah, 4, 5, 2, 3, 1. Sorry. Whew. All right, now let's just take a look at where I built this tree up. Actually, we haven't even looked at that. I've been talking about this tree and how I traversed it, but I didn't talk about how I built it. Now, in my tree class, I don't actually have a way to build a tree. I have a way to traverse a tree and print a string out from it. I have a way to make the root for the tree, but I don't have any way to add any nodes into the tree. So I actually had to do that by hand. So I created a node 1 and a node 2, created these two things. Then I created a new node 3 and I put 2 on the left and 1 on the right. Remember how a net works up here? We have data, then a left node, then a right node. So I put 2 to the left of 3 and 1 to the right of 3. Then I created a new node 4 and a new node 5, and I put 4 on the left of 5 and 3 on the right. So this is then this tree here. All right, so this is our first video on trees. I think that's enough for now. And in the next video, we're going to talk about how we can actually add a method to this tree class where we can insert nodes and not have to build them by hand like this.